Okay, welcome back. This next problem is QID 5847, and this is for thermal hydraulics section of the generic fundamentals exam. Alright, first thing we do when we solve problems is we look at the numbers, right? So 26 psig, so there's a telltale sign. We may need to change that to psia. 34 psig, 2 psig, and 8 psig. I don't see any other numbers. Got a drawing. So now we read the question. Refer to the drawing of a section of pipe that contains flowing subcooled water. See the figure below. Given pressure at P1 is 26 pounds. There's P1. Pressure at P2 is 34 psig. Pressure change due to velocity is 2 psig, and pressure change due to change in elevation is 8 psig. So the question is, the pressure decrease due to friction head loss between P1 and P2 is blank, and the direction of flow is from blank. Okay, so this is one to know the direction of flow, right to left or left to right, and how much head loss is occurring between points 1 and point 2. Alright, so at point 1, we're going to have to put some variables up. We're going to call this elevation 1 or Z1, and the fluid is going to be traveling at a speed V1, and it's also going to have an area of area 1. And then at P2, it's going to be at an elevation Z2. It's going to have a speed of V2. It's a comma. And it's going to have a cross-sectional area that's going to be different. See how it's bigger? You got this reducer here. Alright. So how do we figure out the pressure decrease from head loss? Well, we're going to use our general energy equation. So if you go to the generic fundamentals handout sheet, you should have in the second column this equation. And that should be equal to 0. Now that equation is good for ideal conditions, but in real conditions we have head loss. So since we're looking for head loss, we can say that all these variables, pressure, energy, speed, and elevation change, will add up to 0 in a real or in an ideal pipe. But in a real pipe, instead of 0, that is going to equal head loss. Now head loss from where to where? So since this is pressure 2 minus pressure 1, this is going to be the pressure drop from 2 to 1. This is going to be speed or kinetic energy from 2 to 1. And this is going to be potential energy from point 2 to point 1. And that, of course, is going to equal head loss from point 2 to point 1. Real pipe. Okay? So, we already know that this one, the pressure drop, is going to be 34 minus 26 pounds. It's going to be pressure 2 minus pressure 1. And we know what this one is going to be. We have to figure out which one's bigger. Where is water going faster? So to figure out the different speeds, right? So the first thing we do is V2 greater than V1 or V1 greater than V2? That's the first question we're going to answer. And the way we do that is we say mass flow rate at point 1 is equal to mass flow rate at point 2. Which makes intuitive sense, right? Everything going in is coming out. Just changing speed, apparently, because we're changing area. And so mass flow rate is equal to density at 1, area, cross-sectional area at 1, and speed at 0.1. That's going to be equal to the density at 2 times the cross-sectional area at 0.2 times the speed at 0.2. Alright, so since density 1 is going to be pretty much equal to density 2, no appreciable difference, we're going to cancel both those. Okay, so now we've got area 1 times speed at 1 is equal to area 2 times speed at 2. Okay, now since the area at 2 here is going to be greater than the area at 1 because the diameter at 0.2 is going to be greater than the diameter of the pipe at 0.1. So since area 2 is greater than area 1, speed at 1 is going to be greater than speed at 2. So since these two terms are equal, if your area goes up here, you have to slow down, or in order to make that better. And that's going to make V1 bigger than V2. So, and then since V1 is greater than V2, well then V2 squared minus V1 squared is going to be a negative number. Alright, so see, so right here we're going to have a negative for that. Okay, and now the potential energy, right? Now we got to figure out part 2. Is the potential energy positive or negative? That's the second question we got to answer. So we look at our drawing, we got Z2 up high and Z2 down low. We'll just define that as up high at Z1 and say Z1 is greater than Z2. Z1 is greater than Z2. Okay, so Z2, so therefore Z2 minus Z1 is going to give us a negative number. Alright, so we're going to get a negative number for kinetic energy, negative number for potential energy, and they've given us all of this information. Okay, so pressure at P2 is 34, pressure at P1 is 26 psig. So go back to this equation. Plus speed at 2 squared minus speed at 1 squared over 2 times g sub z plus z2 minus z1 g over g sub z equals the head loss from point 2 to point 1. So they have given us the change in pressure from point 1 to point 2, 34 minus 26. So it's going to be 34 minus 26 psig plus the pressure change due to velocity of 2 pounds, 2 psig. But we know that since V2 is greater than V1 is greater than V2, we're going to have a negative number. So now's the point where we plug that in. And plus the change due to potential energy or elevation. And since Z2 is greater than Z1, we know that's going to be a negative number. And that change, that pressure difference is 8 pounds due to elevation. 8 psig. And that is going to equal the head loss from point 2 to point 1. So what do we have? We have 8 psig minus 2 psig minus 8 psig. And that equals the head loss from point 2 to point 1. So 8 minus 8 is 0, so the head loss from 2 to 1 is equal to minus 2 psig. Now that also means that the head loss from point 1 to point 2 is a positive 2 psig. So that means flow is going from 1 to 2. Flow is going from point 1 to point 2. Flow is going from left to right. So left to right, left to right. It's not right to left, it's not right to left. Now the head loss is going to be minus 2 pounds or 2 pounds, depending on which way flow goes. It's not going to be 4. So the correct answer is A. The pressure decrease due to friction head loss between P1 and P2 is 2 pounds gauge, and the direction of flow is from left to right. That is our answer. We've checked it, we've reread it, and we were careful, and we made sense on all of our equations. We just didn't scribble down some gobbledygook. That's how I would like you to solve these problems. And they're relatively new, so keep that in mind. All right, thank you. We'll see you again.